Hello there, students. This is Mr. Sharkey. Today, I'm going to be explaining to you how to build your own rockets. So you'll see I have a multitude of different rockets here in front of me. So the first thing we want to do is let's talk about the basic parts of a rocket. So to start with, we have the entire body of the rocket, which is right here, the entire length of the rocket. That is considered the body of the rocket. Here at the tip, this is considered the tip of the rocket. So you'll see it comes to a point that is to make sure that it's more aerodynamic. And then on the back side, we have different kind of wings that we can put on it. This one, for instance, has triangle-shaped wings, and it has 3 different wings on it. However, if we look at the other one, this one has different shaped wings. This one still has 3 wings, but they're shaped differently. These ones are considered Idaho-shaped wings. And then the third one that I have, this one actually has 4 wings on it, and these are just rectangular wings that I have on it. But those are the different parts of a rocket. So what I'm going to do now is I'm going to cover with you how to make your own rocket. So now let's talk about how to make your rocket. When you come to class next time, you'll notice there are a bunch of different PVC pipes located in the back of the classroom. They're all the exact same size because this is the size that we'll be using to launch your rockets. So when you come to class, you want to first find one of these PVC pipes. You're going to take your construction paper and you're going to line it up with these, and you are going to roll it tight. And now you want it tight but not too tight, because if you get it too snug, that's when your rocket will explode and kind of destroy itself when it goes to be launched. So you want it to be snug but not too snug. And then once you have this made, we'll go ahead and tape this together. So we'll grab a piece of tape here. We'll tape it up. And again, I always say you can't use too much tape. The more tape, the better it's held together. So I use 3 strips of tape when creating the body of the rocket. Alright, so perfect. So here's our body of our rocket. The next thing we want to do is pick out what type of fins you want your rocket to have. So I will have a bunch of different choices for you on the back of the table. We have what we consider our rectangular fin, our Idaho fin, and our triangular fin. So there are 3 different types of fins that you can use. And just for this instance, I want to say that we're going to use the Idaho fin to make the fins of my rocket. So when you're putting the fins of your rocket together, you want to make sure that you get as close as you can to the base of your rocket to make sure that it is stable. So what we're going to do is take a couple strips of tape. I found this easiest if you take your fin and you put half of the tape on that fin, and then take the body of your rocket and put it on. So again, we kind of want it as close as we can to the bottom, something like that. And then we'll take another strip of tape and we will do the same thing, half of it on the fin and half of it on the rocket so that it sticks out just like that. And so now you can vary this however many times or many different ways that you want. You can use 3 fins, you can use 4 fins, you can only use 2 fins if you want. So it is up to you. You're creating your own rockets. So once you have this done, you can go ahead and do this 3 more times for the wings or the bottom of your rocket. Alright, now that we have the fins of our rocket put on, you see I only put 3 fins on, we're going to work next on the cone of the rocket or the tip of the rocket. So what we're going to do here is in the back of the classroom, you'll see there's a bunch of circles like this that are 3 inches long. What you're going to do is take your hands like this, you kind of overlap them, and then you're just going to twist in, and you're going to get this really nice cone shape from it. So it should look something like that. So now what I like to do is just to make sure I have about the right size for the tip of my rocket, I kind of twist it up either a little bit more or a little bit less until it fits about right. So that seems about right for this rocket. So what I'm going to do next is grab a piece of tape and I'm going to tape that cone together. So once it's taped together, I like to use a couple more strips of tape just to make sure that it's really airtight, because again, we are launching these with high pressure. So now the tip of the rocket is assembled, and one thing you can opt to do, now this is one variation you can make of your rocket, is you can take about anywhere from 0 to 4 grams of clay, or in this case I'm using sticky tack, This weighed in right at 4 grams. I'm going to go ahead and stick this in the tip of my rocket. And so when that rocket is flying, it adds a little bit more weight, and it might fly a little bit more straight. So the next portion of this is now to take the body of your rocket and fit it onto the tip of the rocket. And so I always like to take this, make sure it's pretty lined up. That looks pretty straight. So then I'm going to try to hold that. Take a few pieces of tape, and as straight as you can, get those pieces of tape to stick on there. Put one on each side, and usually that holds it pretty well for you to tape it the rest of the time. So now I got the tip of the rocket on there. I'm going to take a couple more pieces of tape and really make sure that this cone is fastened on there really well. So all you need is about 2 or 3 more strips of tape, and your rocket should be good to go. So there it is. Alright, so the last thing I want to talk about before we go into the math portion of this lesson is all the modifications you can make to these rockets to make them fly farther or shorter, whatever you need to get them to hit the target that we're trying to hit. So the first couple of things that we already hit on that we can change with our rockets are the fin or the wing shape. So you can use Idaho-shaped fins, triangular-shaped wings, or, again, rectangular-shaped fins. Doesn't matter. You can also change the number of fins or wings that you have on the rocket. In this case, this one has 4. In this case, this one has 3. Another modification you can make would be to change the amount of clay or sticky tack that's in the nose of your rocket. This will help it either to fly farther, shorter, or more accurate. And then the last thing that you can do is when we are launching these off, you can choose a different angle to shoot them off at, anywhere from 0 to 90 degrees, and that will also affect the flight path of your rocket. So now we're going to go into a little bit more of the math portion of this lesson. Alright, so now we're going to talk a little bit about the math portion of this lesson. Some of the most important information about this lesson is going to be able to calculate max height and the speed of the rocket. Those are the 2 equations that we're going to look at. With these 2 variables, we will then be able to manipulate our rockets and control how far they will travel. So, the first thing we will look at is the shape that a rocket travels when it is in flight. The shape you'll notice is actually a parabola. So then we can see right in the middle of this parabola, we have what we consider our max height. So our max height is as high as this rocket will ever reach. And so in order to calculate the max height of a rocket, we need to know 2 things. The distance, total distance that it travels, and what angle it has been launched from. If we know these 2 variables, we are then able to use this equation right here, which states that opposite equals tangent of the angle times distance traveled. So in this case right here, we know that our angle is 20 degrees, so our rocket was launched at a 20-degree angle. We know that the total distance that this rocket has traveled is 100 meters. We are then able to use these 2 variables to figure out the opposite side. So we would use opposite equals tangent 20, because that is the angle that we were launched at, and then that is multiplied times the total distance that this rocket has traveled. Max height is extremely crucial when we're launching rockets because on windy days, it's really easy for rockets to kind of get knocked off course by a heavy wind. So in that case, if we know our max height on a windy day, we'd want to keep our max height to a minimum. The next equation I want to talk to you guys about is our speed equation. Our speed equation simply states that distance over time will give us our speed of our rocket. Speed of rocket is extremely crucial because if we're able to know the speed that our rocket is traveling, we're then able to calculate distance and other things from that. So, I wrote up an example right here. In this example, we have a rocket that has traveled 150 feet. It took 3.4 seconds to reach that distance. So then if we take these numbers, 150 divided by 3.4 seconds, it gives us our speed, which is right here. And our speed in this case would be 44.12 feet per second. And that is the second of our two equations.